Hey, Mr. Harridan here. We're going to go over the combined gas law here, which includes pressure, volume, and temperature. It's really a combination of all three gas laws. Even has Avogadro's law in it. And so all you do is write down the gas law, which is P1V1 over T1 equals P2V2 over T2. I do not use the ends because the ends are not mentioned in the problem because frequently amount is constant. So anything that is constant in these problems will be crossed out. So you're going to see me use P1V1 over T1 equals P2V2 over T2. The vice president sits over the table. Okay? So here's a worked example here. So what you have to do here is you list your givens, you check your units to make sure that they're all the same, you write your equation, cross out anything that's constant, plug in the numbers, and then write down the gas law name here. So for instance here it says a volume of 7.81 liters. That's my V1. When the pressure is 754 torr. So I know that this is pressure. It's paired with volume, 7.81 liters. So this is going to be P1. What would the volume in liters? So I'm looking for the volume in liters. So that's going to be V2 when the pressure is changed to 1.23 atmospheres. And that's going to be P2. Temperature and amount are constant. So the first thing I recognize here is that this pressure and this pressure are different, right? And we know our pressure conversions on our periodic table. They're listed there for us. So then we convert our pressure over to atmospheres, or you can convert the atmospheres over to torr. It doesn't matter, right? Then you write down your equation, cross off your n's and t's because they're constant. So leaves it with P1V1 equals P2V2, and then you plug in the numbers and solve. And you write down Paul's law. Okay, you ready to see me do example 11.8? Of course you are. Are you ready for this, Darian? You ready? Awesome. Okay, a 5.2 liter sample. 5.20 liters. This is going to be V1 because we know that liters are a measure of volume. Is heated from 25 degrees Celsius. You're right, Darian. You cannot use 25 degrees Celsius because these are based off of Kelvin. We are going to use 298 Kelvin, right? Because we do remember Celsius Kelvin equals Celsius plus 273. If you see me doing that. So I know that 298 Kelvin is T1 and 100 degrees Celsius. You're right, Darian. We cannot use Celsius. We are going to use 373 Kelvin, and that is going to be T2. What is the volume in liters? So we are looking for the volume in liters at the higher temperature if the pressure and the amount remains constant. Okay. So then we check our units. The units are the same. Okay. Then we write down our equation. P1V1 over T1 equals P2V2 over T2. Now notice it says the pressure is constant and the amount. You never see me write down moles for this equation. So what we're going to do here is cross out our P1 and P2. So we're going to use the equation V1 over T1 equals V2 over T2. So this is going to be 5.20 liters over 298 Kelvin equals V2 over 373 Kelvin. Okay? This is a proportion. So what you do here is you cross multiply and divide. What are you going to cross multiply? Well, the variable is here. So you are going to end up multiplying these two numbers. The number I didn't circle, I am going to divide. Okay? Plus we should realize that the the temperature is going up. The volume should go up because this is a proportion. And it's Charles's law, which is direct. Did I tell you it's Charles's law? Yeah, it's Charles's law. And when we solve this, we get 6.51 liters. Round to 3 sig figs because that's what we have in the problem. Thanks, Darian. Let's move on to the next problem here. Here we go. A gas is found to have a pressure of 700 torr. 700 torr. That is going to be P1. And is at a temperature of 54 degrees Celsius. You're right, Darian. We cannot use Celsius. We have to cross that out, and remember, Celsius plus 273 equals Kelvin. So here we're going to use 327. Let me double check that though. Yeah, 327. Okay, so T1 is 327 Kelvin. If the volume of the gas under these conditions, so we're still under the one conditions here, so this is going to be V1, is 3.21 liters, what is the original volume in liters? That's going to be V2. When the temperature was 20 degrees, you're right, cannot use Celsius. We're going to use 293 Kelvin. And the pressure was 700 torr. Okay, check the units, make sure it's torr, Kelvin, Kelvin, liters, liter. So we are okay on units. So we're going to write down our equation here. P1 V1 over T1 equals P2 V2 over T2. The vice president sits over on top of the table. Okay. Now, do you see that P1 is 700 torr and P2 is 700 torr? Do you know what that tells me? The pressure's constant. It's not changing. Love the bells. Don't you love the bells, Darian? Yeah, I love the bells too. Okay, so we can cross out P1 and P2. Okay, now you can solve it with those numbers in there. You're still going to get the same answer. Okay, so now we're going to do our equation here, which is 3.21 liters over 327 Kelvin equals V2 over 293 Kelvin. Okay, so notice here that the temperature is decreasing, so the volume should decrease. So we should get an answer that is smaller than 3.21. My variables here, so I would cross multiply these two numbers, and then I would divide by that number. I will get a V2 of 2.88 liters Charles in Charge was on TV, starring Scott Baio, of course. So this is Charles's Law. Thanks, Darian. I'm glad you're here to encourage me. Okay. Example 1110. A 3.5 cubic foot sample of nitrogen. 3.50 cubic feet. 3.50 feet cubed. Okay? Because cubed means to the third power. Feet cubed, this is a volume, so this is going to be V1. Whose pressure is 79.1 kilopascals. So we have a pressure 1 of 79.1 kilopascals. Expands to 6.1 cubic feet. So now we have a V2 of 6.10 cubic feet. While its pressure also changes to 680 torr. That's another pressure. P2 is going to be 680 torr. Okay? At the expanded volume was 680 torr. The temperature of the gas is found to be 28 degrees Celsius. You're right, Darian. We can't use Celsius in gas law. We have to use Kelvin. So this is going to be 301 Kelvin. the temperature of the gas is found to be 301 Kelvin at the expanded volume. So this is actually a T2. We are going to look for T1 because it says what is the original temperature in Celsius. Now we're going to check our units. Feet cubed, kilopascals, torr. Oh, that's not good. That's not good. So we're going to take our 79.1 kilopascals. Not okay. And we're going to have to convert it over to torr. kPa on the top, kPa on the bottom. What are you going to convert to? Torr. Remember that swish. Remember that these numbers are on the periodic table on the back. It's going to be 760 torr equals 101.33 kilopascals. And we get an answer of 593.26 torr. So I cross this out. That number doesn't exist anymore. And we're going to use 593.26 torr. Okay, we're going to write down our equation. P1 V1 over T1 equals P2 V2 over T2. Vice President sits on top of the table. Okay. There's nothing constant in this one, so we're just going to have to solve this. So we're going to start off by putting in 593.26 torr times 3.50 liters. We are looking for T1 equals 680 torr times 6.01 feet cubed over 301 Kelvin. Okay, this is another proportion here. So here's how we're going to solve this one. The variable's here, right? So you're going to circle everything that is not with the variable. So you would cross multiply all of these numbers. Now this number right here, we didn't circle it, so we would divide by this number. We didn't circle this number either, so we are going to divide by that number as well. Okay? And then we get T1 is equal to 151 Kelvin. The question says, what's the original temperature in Celsius? Oh, jeez. So then you have to subtract 273. And once you subtract 273, you get negative 122 degrees Celsius. That's the correct answer. And this would be the combined gas law. Thanks, Darian. You're awesome too. Okay, you guys are champions. The legend is out.